systems of linear inequalities. These are going to be lines that you shade either left or right or up or down from based upon when we graph it. So it's going to be graphing just like yesterday with the system of equalities. But then we're going to add in some more steps. Just like before, if on your absolute value inequalities, if there's no bar underneath it, meaning it's just like a less than or a greater than, it's a dashed line. If there is a bar underneath it, meaning less than or equal to, or greater than or equal to, it's a solid line. So let's talk about this first one. X is greater than 1. So I need to graph everything where X is greater than 1. And so for the values to be of X to be at 1, it needs to be somewhere up and down from positive 1 on the x-axis. So somewhere along this lines. And just like with your lines, you're going to draw arrows at the end. And this one happens to be dashed, so I'm going to come back in here and I'm going to dash some spots out. You can draw it dash as you go. Whatever method works, as long as I can tell where the line is and that it's dashed, it is good. Now, when I have a dashed line, it says X is greater than 1, so the values of X being greater than 1 is going to go this way from it. I'm drawing these little arrows in. Actually, let me do it a different color so it can kind of stand out. Show my thinking. Greater than 1 is going to be this way from the line. Now I'm going to do my green line the same way. I'm going to start with identifying the information I need to graph it. So my y-intercept is 0, -7. And so on the y-axis, I'm at -7, and I put my dot. My slope is 1, which means 1 over 1. And so that means it's positive, so it's going to be going up 1 over 1 each time. And I have a solid line, so that whenever I draw my line actually in here, I'm not going to actually go back and dash. And so each of these are the points. And it's solid, and I draw my arrows at the ends. Now, great, less than, y is less than or equal to x minus 7. So less than, what would be less than is the numbers that are smaller. So it would be down here. When we do this, you're actually going to be looking for where the overlap is between these two shading areas. And so I'm going to talk about this in region areas. Is it going to be in region 1, 2, 3, or 4? And if you look, if I need to shade both to the right of the purple line and below the green, that would put my shading in that red, green, or in that green area. So I'm going to shade anything below here. And what that really means is any ordered pair I choose below that line and to the right of the purple line is a solution. But also some of the solutions are any numbers along this green line that border that red. But no solutions would be on that purple line. So anything I choose over here would come out as true if I plugged it into both equations. Let's do one more, and then y'all will get to start working on the assignment. So let's look at these two. What's different here is now we don't have it solved for y. And so just like when we were solving yesterday's for y, we move the x away first, leaving us y is less than -2x, and the 3 was positive, so plus 3. Now, there's nothing being multiplied to the y, so I am done with that one. I just need to identify both my y-intercept, which is at 0, 3, and my slope, which is -2, which means -2/1. That means I fall to right 1. So starting at 0, 3, I put my dot, and then I fall to right 1, and keep doing that as I go throughout the paper. Oops. And this one needs to be dashed as well because there's no bar underneath. And so let's go back in and dash along that line. As long as I can tell it's dashed, it's good. Now let's look at the next equation. Oh, and that one, we would need to shade which way? We would shade less than, which is down below or to the left. And let's look at the green equation, or inequality, excuse me. We need to move the 3x to the other side. And so we have -y is less than or equal to -3x plus 2. Then I have another problem. This has a negative sign in front of that y. So when I divide by -1, my inequality has something happen to it. It causes that inequality symbol to flip directions. It's now going to be greater. And so y is greater than positive 3x minus 2. So my y-intercept for this one is going to be 0, -2. And my slope is 3, which means 3/1 is my slope. So now I go up here to -2. I'll put my first dot. And then I'm going to have the slope of positive 3, so rise 3, right 1, all the way along that line. So when I drew that green line in and put the arrows on the end, now I need to go back and dash because it did not have the bar underneath. So if I am greater than the green, that means I need to be above. And so if I'm shading everywhere above, it would go this direction. So if I go through and I want to number the little areas, 1, 2, 3, and 4. I need to be below the purple line, but yet above the green line, and that leaves that area to be here. And so I go back and I shade that region. Do you notice how that when I shade this region, I did not stop at the x-axis? It crosses that x-axis. It shades everything. The only borders it worries about are those regions created by the purple and green line. Now, this one, since both of them were less than or greater than without an equal to, that means the lines are not part of the solution set. So I can't plug anything in on one of those lines and come out as true. It would have to be in that red shaded region to come out as true.